In this video, we're going to start looking at circles. So a circle, we all know, you can see it on the wheel of your tire every morning you go out. We can see circles everywhere when we look around us. So it's a set of points on a plane that are equidistant from the fixed point in the middle, which is all called, the radius in the middle here, the radius. And the plural of radius is radii. So what else do we know about circles? Well, what's a chord? A chord, you can see here, any line segment across the circle is a chord. Radius from the center to the outside, and then diameter all the way across. An arc is any part of the outside. It could be the whole thing, and you guys know from your earlier study of geometry, 2 pi r is the length of the arc of a circle. But if we only want a portion of it, we'd multiply by whatever size the angle is. Sometimes they call it theta over 360. So if it was a quarter of a circle, 90 over 360 will give you a quarter, and so on. But we can do this with any size angle. It could be 27.1 degrees. What about a tangent? Well, if we have a radius, a tangent is a line that touches off a circle at one point and one point only, and a tangent creates right angles at the point at which it touches the circle with the radius. A sector of a circle, like when we have part of an arc, we'll be able to connect it to the center. That's a sector. Think of your slice of pizza when you're ordering your Domino's. And now let's look at some circle properties. So the old theorem that we had to prove, this theorem 19, an angle at the center of a circle standing on a given arc is twice the angle at any point on the circle standing on the same arc. And this is where, if we have the arc being here, we have the angle BAC up here, and BOC here, and the internal one, the one inside, is always twice the one on the outside. A nice simple explanation of this is, if we have a diameter, let's do an angle standing on the same arc from there to there. Well, if a diameter is 180, what does that make the angle here standing on the arc? It makes it 90. So in fact, any angle that you draw using a diameter, it doesn't matter whether it goes from there to there, that's going to be 90, the wrong way around, that's going to be 90 degrees in there, because it's standing on the arc of a circle. Similarly, if I go from there to there to there, that's also going to be a right angle, and they will all be right angles standing on the diameter. So it's just another part of this theorem, when the angle is actually, when the arc is actually the diameter. So two angles standing on the same arc, well, these will be equal, that's obvious. And obviously both of them are, if we added them together, we'd get that angle in there, or that angle is twice B, or that angle is twice D. Okay, so make sure you have all of these just sketches. We don't have to prove any of this anymore. Junior cert, your lives are really easy. So let's have a look at cyclic quadrilaterals. So a quadrilateral, a cyclic quadrilateral, just a four-sided shape that fits inside a circle here. And they have some properties. So what are they? So A plus C is 180. Opposite angles equal 180. And B plus D is 180. And if the opposite angles of a quadrilateral sum to 180, then it's cyclic. It means that we could draw a circle around it like this. So that's a cyclic quadrilateral. And this is the one I've already introduced. Any angle standing on the same arc as the diameter is going to be a right angle at the top. You can see there's another one here. Draw a couple more in yourself into your copy and measure them. If you want, they will all be 90. The magic of geometry and maths, and you can see a kind of pattern emerge here with these three. We could keep going with them. So corollary 3, each angle in a semicircle is a right angle. And corollary 4, if the angle standing on a chord at some point of the circle is a right angle, then the chord, obviously BC, has to be a diameter. So now let's look at some questions dealing with circles.